So today we're going to talk about how to solve a system of equations with the substitution method. Okay. Yesterday we learned how do we solve a system of equations with graphing, and that is a great method if both of our equations are in slope-intercept form. So we can just graph those and see what is the ordered pair if they share, if any. And here's a second method of substitution. Okay, so the substitution, it's a method by solving the equation by substituting the equations with one another. This is a great method when we already have a variable that is solved for. So for example, here you notice on the left-hand side, we have two equations. I have my y equals 6x, and then I have a second equation, 2x plus 3y equals negative 20. Okay. Because my y is already solved for, we know that y equals 6x. This would be a great example to use the substitution method. What we're going to do here is, in our equation, everywhere that there's a y, you're just going to highlight, substitute in that 6x. And now the only variables we're left with are that x variable, and now we're solving for x. Okay? So here are the steps. Okay? So the first thing that you need to do is you're going to need to solve one of the equations for either x or y. It does not matter which one. Okay? And my recommendation is always solve for a variable that will be the easiest to isolate, okay? Meaning it has a coefficient of 1. Okay. Once you have solved for one of those variables, you're going to be substituting this expression into the other, okay? So we're going to substitute this expression into the other and solve for the remaining variable. So in our example over here on the left, we already knew that y equals 6x. So we substituted in 6x everywhere there was a y, and now we're solving for x. Okay. So once you have that answer, here we were able to locate what x equals. Now we still need to find y, so we're just going to substitute this answer back into the revised equation and solve for the other variable. Okay. I know it's a lot of steps, but we're going to do lots of practice and you'll see how this system works. Okay. So let's take a look at number 1 together. So here we're asked to solve by substitution. So the first thing, substitution is a great method if one of my variables is isolated. So here we go. I already have y solved for. I know that y equals 6x. So I'm going to take my second equation, and now wherever there is a y, I am going to substitute in 6x. All I did was substitute in a 6x for that y value. Now notice I no longer have a y, I only have x's, so we can now solve for our x variable. Okay. So we're going to use the don't call me after midnight method. Okay, so I have my 2x, I'm going to distribute, plus 18x equals negative 20. And now we can combine these like terms. 20x equals negative 20. And now, since I need to solve for x, I'm going to divide both sides by 20. And I'm left with my x equals negative 1. Okay. So there's the first part. You're not done because remember, a solution to a system is an ordered pair. So I have my x value. Now I need to solve for my y value. Okay. So what you're now going to do is choose one of the two original equation, and you're going to substitute in for y, okay, to find y. So it matters not which equation you want to use. I'm going to go with the easiest one for me, the one that I don't have to do so much manipulation, and that's my top one, that y equals 6x. I need to solve for y, so wherever there's an x, I'm going to plug in that negative 1. So I have y equals 6 times -1. And now I'm solving for y. Y equals 6 times -1 is -6. Okay. I now have all of the components necessary for my solution. So in this particular equation, my solution to this system is -1, -6. Let's take a look at the next one. Okay. So here we're going to solve by substitution. Okay. So the first thing is I need to make sure that one or more than one of my equations, I have isolated the variable. You'll notice here that both of these equations are already solved for y. Okay. So let's just choose, matters not, I'll choose this equation. Let me rewrite it. I have y equals 2x minus 2. Okay. And now I'm going to substitute this in everywhere there's a y. So instead of y, I'm going to substitute x plus 2 equals, bring this down, 2x minus 2. You notice when they're already both substituted for y, all I need to do was set them equal to each other. Okay. So now that I have gotten rid of my y, all that's left to do is to solve for my x. So I'm going to subtract 2x from both sides. And that leaves me with -x plus 2 equals -2. And now I'm going to subtract 2 from both sides. -x equals -4. And there's a last step because I need those variables to be positive. I'm going to divide by -1. I have x equals +4. So I have my x variable solved for, but now I need to substitute in to find y. Okay. So I'm just going to choose one of these equations. I'll just go with this one here. Okay. I have y equals x plus 2. Now wherever there's an x, I'm going to substitute my x value of 4. So I have a 4 plus 2. And now we're just solving in. My y equals 6. So now the solution to this equation is I have an x value of 4, y value of 6. Now you can always check the answer for number 2 by plugging it into Desmos and graphing it, because as you know, they're both in slope-intercept form. And when you do that, you're going to find the same solution for common -6, okay? Because the problem told us to solve by substitution, that's the method that we had chosen. But you can always turn an equation back into slope-intercept form and graph it. Go ahead and try number 3 on your own. So here for number 3, you'll see that because x was already solved for, I went ahead and I went back up to my first equation and I plugged in y plus 1 wherever there was an x. Okay. So you see here is my second step here. When I did so, okay, I then needed to distribute this negative. Okay. Notice what happened is both of my y's canceled out and I was left with a -1 equals 1. Since this is not a true statement, there is no solution to this problem. I hope this video helped in solving systems of equations by substitution method. As always, feel free, come to Mav Academy, request tutoring if you need more help. Also be sure to check out the completed version of these notes on your Schoology page.